Hello and welcome to this video on how to conduct multi-group path analysis in the Mplus software. My name is Geiser, I'm an instructor with QuantFish, and on this channel I present weekly statistics tutorials. I usually talk about multivariate statistical methods including structural equation modeling, factor analysis, latent class analysis and multi-level modeling. If this is something that interests you, then please subscribe to this channel. Also, don't forget to check out the description for additional resources including free workshops and other workshops that I offer through QuantFish. In this video, I want to show you how you can conduct a path analysis for multiple groups in the Mplus software. Why is this something that might be useful for you? Sometimes when we analyze path models, for example, mediation models, we have additionally multiple groups that we would like to compare. So perhaps a grouping variable is a potential moderator variable. Maybe the path model is different for males and females, or perhaps a path model differs across treatment and control groups. And then multi-group path analysis is a convenient way to study a discrete or categorical moderator variable such as gender or treatment group, because in multi-group analysis we can formally compare the path coefficients across two or more groups. And so this is something that I want to show you here, and then perhaps you can apply this to your own data when you have a categorical moderator variable or you want to see whether a path model is the same or different for specific groups. In my data file mgpath, I have four variables. G is the grouping variable, so the discrete moderator variable that I'm considering here, and then X is my exogenous variable, M is my mediator variable, and Y is my dependent variable. The assumption is that X, M, and Y here are continuous variables, although X could be binary or dichotomous. G is a binary grouping variable with groups 1 equals control and 2 equals treatment. So here we're comparing a control group and a treatment group with regard to this mediation model between X, M, and Y. You can see that I specified the bootstrap option here for testing indirect effects. That is a method of choice to test the product of coefficients for statistical significance. In this case, the product of the A and B coefficients. The path A is the path from X to M, and then the B path is the path from M to Y. And so the product A times B gives us the indirect effect of X on Y in this model. The model statement here specifies that M, the mediator, is regressed on X, so that gives us the A path, and then the outcome variable Y is regressed on M, which gives us the B path, and on X, which gives us the C prime path in our simple mediation model. I also included the model indirect subcommand here in the model statement so that Mplus will print the indirect, direct, and total effects separately, and will also then test them for significance using the bootstrap method, and here specifically the bias corrected bootstrap confidence intervals that are printed when you include the statement C interval BC bootstrap in parentheses in your output command. So the C interval BC bootstrap subcommand in conjunction with the analysis bootstrap equals 1000 allows us to run the bias corrected bootstrap method and obtain bias corrected bootstrap confidence intervals for the indirect and other effects. This has the advantage that we obtain asymmetric confidence intervals, which are more appropriate for the product of coefficients. Here A times B is the indirect effect, so that's a product of coefficients, and that tends to not be normally distributed, and therefore asymmetric bootstrap confidence intervals are better suited to test the statistical significance of the indirect effect than would be a simple standard error and Z statistic. Notice that this grouping command here is key in the input file. If we didn't include that grouping command, Mplus would not run this as a multi-group analysis. So this really is the key command here that makes Mplus run this as a multi-group analysis, meaning the coefficients are estimated separately for the control and treatment groups, and the default in Mplus is with path analysis that all coefficients, all path coefficients will be allowed to differ, all intercepts of the regressions are allowed to differ, and also the residual variances of the regressions are allowed to differ under this setting that I'm showing here. Later on, I will also show you a constrained version of this path model in which the path coefficients are set equal across groups. Now, this grouping command is unspecific, so to say, or general. You can apply that also to factor analysis. You can apply this to a latent path model, a structural equation model, and other models. And it's used whenever you want to compare multiple groups in a simultaneous analysis. Now let's take a look at the output file for this model. You can see here that in the control group we had 179 individuals, in the treatment group 207 individuals, and in total 386 people. When we scroll down, we find the sample statistics, means, covariances, and correlations for the control group first, and then for the treatment group. Below are other sample statistics or descriptive statistics for those two groups, including the skewness and kurtosis, minimum and maximum percentiles, and the median that then you also get for each variable and each group separately. Next are model fit statistics, and the model fit statistics in this case are not very interesting because this model is saturated. We're estimating all path coefficients in both groups, all error variances, all intercepts, and there's nothing, no parameter is set equal across groups, and therefore this model is saturated altogether, and as a result the chi-square value is 0. There's no chi-square contribution from any of the groups, and also the other fit statistics here are not meaningful for us. What is meaningful though are the model results, which give us the path coefficients, and you can see that first we obtain the control group coefficients. So here we have m on x, this is our A path. The A path is 0.344, an unstandardized metric, and the p-value is very small, indicating that the A path is statistically significant. The m to y path is given below that, it's 0.199, also an unstandardized metric here. You can see this path is also significant at the 0.05 level, whereas the C path, y on x, is not statistically significant at the 0.05 level in the control group. We obtain the same coefficients for the treatment group. Notice that they take on different values because they're not constrained to be equal in this version of the model. Here you can see the m on x path or A path here is 0.657. It was 0.344 in the control group, so there may be a difference here. You can see this is also statistically significantly different from 0. We don't know if this is a statistically significant difference between these coefficients yet, because we don't have a formal test of that in this output, but I will show you later how you can formally compare those coefficients in the Mplus software. Furthermore, we can see that the y on m path is 0.053 in the treatment group, and that it's not statistically significant. So in that group there may not be a substantial B path, whereas in the control group we did find a significant B path. And then also the C path here is 0.147 in the treatment group, or C prime path, and in the treatment group this is statistically significant. So you can see that these can differ across groups, and also the intercepts can be different for those two regressions. Here we have the intercepts for the control group, here we have the intercepts for the treatment group, and they are different, and so are the residual variances between control and treatment group. So in this default version of the output, everything can differ between the groups. Now below that you can find the standardized parameter estimates, and then further down below you get a summary of the total indirect, specific indirect and direct effects. We can see here that in the control group the total indirect effect is 0.069, and when we use the standard error that's provided here for significance testing, it would be significant at the 0.05 level. The p-value is 0.035. Now, as I mentioned earlier, a better way to test the statistical significance of an indirect effect is by looking at the bootstrap confidence intervals, which are asymmetric, and then determining whether the confidence interval for a given level of alpha contains 0 or not. And so I will show you this next. Notice that also here Mplus gives us the total effect, which is the sum of the C prime path and the indirect effect A times B. And then also the direct effect is given again, so that's the C prime path that we've already seen above. And you get the same information also for the treatment group, so you can test this separately or look at this separately for control and treatment group. Again, you can also look at it in standardized metric, and then when you scroll further down, we obtain the confidence intervals for all model results, and first we get them for the point estimates of the path coefficient. So here we again find our A path, here we find the B path, here we will find the C prime path in unstandardized form, first of all under estimate, and you can see to the left are the lower limits of different confidence intervals, to the right of the point estimate are the upper limits, and so Mplus provides a 10% confidence interval, which you would find here under lower 5% and upper 5%, and then a 95% confidence interval, which you find under lower 2.5% and upper 2.5%, as well as a 99% confidence interval, the limits of which you can find under lower 0.5% and upper 0.5%. Now, this is not so interesting for us here for those point estimates, but it is interesting for the indirect effect, and that's found further below the standardized confidence intervals, where you can see confidence intervals of total indirect, specific indirect, and direct effects. And so here we find again the point estimate of our indirect effect A times B, and when we look at the 95% confidence interval, so again we're looking at upper 2.5% and lower 2.5% and upper 2.5%, which are the limits of a 95% confidence interval, we can see that the 95% confidence interval ranges from 0.016, which is slightly above 0, to 0.147, which is obviously also above 0, and so this means this confidence interval does not include 0. So the 95% interval doesn't include 0, and this allows us to conclude that the indirect effect is statistically significant at the 0.05 level. Now, if we were to test at an alpha level of 1%, so rather than 5%, 1% more conservative level of alpha, then we would take a look at a 99% confidence interval, the limits of which we find right on the edges of this table. So here under lower 0.5% and upper 0.5%, we find the limits of a 99% confidence interval. And you can see that that interval does include 0 and ranges from negative 0.006, which is below 0, to 0.173, which is above 0. So 0 is now included. And this means that the effect is not statistically significant at the 1% alpha level. So if you were testing at an alpha or significance level of 0.01 or 1%, then the indirect effect would not be significant. If you're testing at a 5% alpha level, then it is significant because the 95% confidence interval does not contain 0. So that's how this works. And so this is for the control group, and we can look at it also For the treatment group, you can see for the treatment group, things look a little different. Here again, we find the limits of the 95% confidence interval, and for the indirect effect, they range from negative 0.057 to positive 0.123. So this effect is not statistically significant in the treatment group, even at the 5% alpha level. So there's no significant indirect effect here in the treatment group, but there is a significant indirect effect in the control group. That would be our conclusion. Now, you might want to compare coefficients formally. So it might be a good idea to test whether the coefficients between the control group and the treatment group differ statistically. And you can do that by running a constrained path analysis for multiple groups. And so this is what I want to show you next. So let's go to a different output file that is labeled multigroup path analysis _ constrained. And so in this analysis, I set the path coefficients equal across groups. And how is this done in Mplus? It's done simply by providing labels for the paths. So here, in line with common conventions, I called the X to M path A, I called the M to Y path B, and I labeled the X to Y path as C. And so when you put these labels here in parentheses, then Mplus will assume that those parameters that are labeled are supposed to be held equal across groups. So they will then be constrained equal automatically. And in addition to that, you could also test whether intercepts are the same across groups. So that would work in a similar way. If you specify the intercepts for these regressions, you could set them equal. For example, for the M intercept, you could say M is my intercept, and then I'm giving this a label, for example, inter M or something like that. And then this would also be set equal across groups if you wanted to test that. And the same for the residual variances. You could specify M is the residual variance for the mediator, and then say this is, for example, residual M. So all you have to do is specify the parameter and give the parameter a label of your choice, and then Mplus will set the parameter equal across the groups in your analysis. Now let's check out the output file in which I only did this for the three path coefficients A, B, and C prime. And so let's go down again here. When we scroll down to the fit statistics, we can see that now this model is non-saturated, and you can see that from the fact that the chi-square value for the model fit test is now non-zero. It's 21.309. The test has 3 degrees of freedom, and the p-value is 0.0001. So what does this mean? This means that the model is rejected. So this path model with A, B, and C paths set equal across the groups does not fit well. And the chi-square test shows us this. It's a significant chi-square value, which indicates a discrepancy between the observed data and what we specified in our model. So this indicates that either the A or the B or the C path or 2 of them or all 3 of them are different across groups. Now we don't know, are they all different? Is only one different? The chi-square doesn't tell us this because it's a 3 degree of freedom omnibus test. It simultaneously tests the equality of all 3 parameters A, B, and C. And so if you wanted to know this in more detail, you'd have to conduct individual tests of these path coefficients. All this tells us now is that something is not the same across groups, either A or B or C or a combination of those coefficients. And so the fit then is also poor according to RMSEA. You can see that's a high RMSEA value. Also, we have a poor fit according to CFI and TLI. And so this clearly doesn't work. So we do have some sort of moderation effect here of our control versus treatment groups, because these coefficients are not all the same across groups, so the relationship between some of the variables is dependent on which group you're looking at, so there's some kind of moderation effect here going on. Now we can verify in the output that Mplus indeed has constrained the parameters to be equal across groups. Here you have the A path again, 0.531, and you can see in the treatment group it's the exact same value with the same standard error and the same test statistic. And also when you look at the B and C prime paths, you can see that those are the same across the two groups now due to these equality constraints. And so with a chi-square test, you can test whether those constraints are acceptable or not. In this case, we found that some of the coefficients, or at least one of the coefficients, differs significantly across the two groups because the chi-square test here was significant. I hope you found this video useful to learn about how to specify multi-group path analysis in the Mplus software. If you liked the video, please consider subscribing to this channel, and also don't forget to check out the description for additional resources, and I'll see you next time.